Okay, so we have 4.3. We're going to model different data. The one that we're going to talk about is talking about a temperature in the morning, or like all day. So if we think about, first of all, let's think about, I am going to use this. So hold on. Oh, here. Okay. So, when we are modeling, the only thing we've done before is linear, which would be a straight line. Oh dear. Which would have been a straight line when we model linear. Today we're not modeling linear, we're modeling quadratic. What does a quadratic graph look like? There's two ways. There's this smiley face, like this, and there is a frowny face. When we are talking about a lot of things, it can be modeled with quadratic. If I'm throwing a ball in the air, like I'm going to throw a football or a baseball or whatever, it's going to go up, and then where's it going to go? Down. So it's modeled quadratic, not linear. Okay, I'm not going to throw it and it's going to go to outer space. I mean, I'm really strong, but
not like throwing it in down.
Well, correct. But let's say we have gravity, so it's pulling it down. When you guys get into physics, which I don't think anybody's in physics because you have to be past algebra 2, but a lot of your modeling looks like this. Gravity, the equation for gravity is actually quadratic and upside down like this, because once you throw something up, it's going to come back down because we have gravity. When we're talking about temperature, so the first one we're going to talk about is, it says a chart shows the temperatures predicted for the day in California. So at 8 o'clock, it's going to start out at like 50 degrees, and then it's going to slowly go up. But what's going to happen to the temperature in the day? It doesn't keep going, or we're going to burn up. What happens when the sun goes down? The temperature starts decreasing. Or if you're in Nebraska, we start out at 42, and then all of a sudden we're at 32. So that happens too. But usually it gets hotter as the sun is up, and then it gets colder when the sun goes down. So we're going to talk about modeling using temperature today for our first example. So go ahead and open up your book to page 211. I'll go ahead and write it up here. 8, 10, 12, 2, and 4, and 6. And we have 52 degrees, 64, this is for the people watching on video, 72, 78, 81, and 76. Okay, so we are going to plug in our calculator this information. But I want to talk about one thing before we start typing into our calculator. Notice that when I go 8, 10, 12, what happens after noon? It starts going 1, 2, 3, 4, 5, 6, 7, 8. So when we're typing in to get our model that looks like this, our x values are going to keep increasing, which is our time values, or they're going to keep increasing. So whenever you're using time, you're going to use military time. So you're going to go 8, 10, 12, then this would be 14, 16, 18, so that your x's keep. Otherwise, your graph is going to be all over the place because it's going back this way. So you want to keep it continuing to the right, okay? So let's remember how we do this. This is going to be our L1. This is going to be our L2. Does anybody remember the magic button that you use?
Yes, second.
No.
Second matrix.
No, that's for matrices. This is for regressions. Stat.
Stats, yeah.
Okay, so we're going to go to stat, and then what do we need to do first with our lists? Clear our lists. So we're going to go down to clear list, hit enter, but remember you have to say what list do you want to clear? L1, and then what do we put? Comma, L2. So we have clear list, L1 is second 1, and then the comma is above the 7, and then I have second 2. So this is what you should see on your screen right now. Everybody got it? Hit enter and it should say done, meaning I cleared my list. Wonderful. So our home button is stat. I want to edit my list now, so what am I going to do?
Click edit.
Edit. You should see an L1 and L2. Tell me if you don't see L1 and L2. Everybody's got it? Okay, so L1 is our input, which is our time. The temperature is depending on the time of day. The time of day doesn't depend on the temperature. You don't say, it's 80 degrees outside, it must be 4:30. Okay, you say it's 4:30, it's 80 degrees. So our time's going in here, and the time we started with was 8, right? So we have 8, enter, 10, enter, 12. How far did we go? And then 14, 16. We went all the way to 18? 18.
Wait, what we click?
Stat, edit. And then you're going to go L1, and you're going to put in 8, 10, 12, 14, 16, and 18. And that represents 8 a.m., 10 a.m., 12 p.m., 2 p.m., 4 p.m., and 6 p.m. Then L2, and you can see it's on your page at the top of 211. L2 is going to be your temperature that we put in. So if you guys want to go ahead and put the temperatures that are at the top on problem 3, you just hit the right key over. And I have 52, 64, 72, 78, 81, and then it starts turning cooler and it goes 76. So what we're trying to find is the equation that models this information. Everybody there? Okay, what's our home button again? Stat. This time we want to calculate something. So we're going to go over to calc. And we used to use 4, linear regression. Now we're going to use 5, quadratic regression, because these are quadratics that we're dealing with. So I'm going to hit enter. And then you just want to take a quick glance to make sure that X is L1 and Y is L2. It should be that way because you have to actually change it to be changed. But since you guys share calculators, you might just want to make sure. And then I'm going to hit enter on calculate. And you should get an A, a B, and a C, because remember quadratic regression, or quadratic, a standard form is y equals ax squared plus bx plus c.
We don't need the r squared.
Well, we do need that. I'll get there in just 1 minute. If you don't have it, I'll get it for you. But our equation is different than when we did linear, because when we did linear, we did y equals mx plus b. And when we did this, it did y equals ax plus b. So you use the a and the b to write that equation. Now we need to fill in y equals ax squared plus bx plus c, because we're talking about a quadratic graph instead of a linear graph. So you're just going to take and fill in these numbers. So I have y equals negative 0.47 x squared plus 14.72x, and then minus 36.12. And that's your equation. Now, how many of you do not have the r squared? Okay. What I want you to do is go second and hit catalog, which is 0. Second catalog. We're going to go down to, I like to hit this button, the x to the negative 1, because the green letter is a D. So it takes you to that section. And we're going to go to diagnostic on. Hit the x to the negative 1, second catalog. Then x to the negative 1 will take you to that section. And then you're going to scroll down to diagnostic on and hit enter twice.
Hit twice.
Yeah, until it says done.
Then I go back to stat.
Yep.
And go back to calc.
Yep.
Okay.
So I'm going to hit diagnostic on twice. And it says done.
Got it.
Then you should be able to go back to your equation, or back to your information. And you should see an r squared value. Does anybody remember what the r squared value tells us? The accuracy. What do we want this close to?
100.
100 or 1, 100% or 1. So this is 0.99, which is pretty accurate. It's following our data pretty accurately. So if I wanted to find out what the temperature would be at, like, say 9 o'clock, I could plug that in and find out what the temperature would be. And it would be pretty accurate if it's following the same trend. But we know weather doesn't follow trends like that, so that's that. Good so far? Okay, I want you guys all on your own, start to finish. I want you to try the Got It that's at the bottom. This is another weather one, but it's talking about Denver, Colorado. Remember to use military time. So instead of writing, 12, 13, 14, 15, 18, 21, is that right? For 3 p.m., 6 p.m., and 9 p.m. You just keep counting past 12. You guys try it and let's see what we come up with. Oh dear. Oh dear. I did this on my computer.
Hers isn't working.
What's it saying?
Error.
So you must. So. Well, you have quad refreshment L1, L2. You got your list, L1, L2, done. So now you go into stat and put your information in. Now you go to edit, you have to put information in. And then hit enter, and then you put in your information. Oh dear. Okay, here's what it should look like when you have all your information in, L1 and L2. And then I go to stat, and where do I go from here? Calc. Which one am I picking? Quadratic. Enter. Enter, 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 enter. And you get your equation. So your equation here would be y equals negative 3.3x squared plus 9.8x plus 15.57. Is this a good predictor?
Very.
Yeah, it's really close to 1. So we're good.
I did it right. I don't know if I put it in the equation right though.
You just fill in that for A, this for B, and this for
I
C.
did wrong.
Okay? Okay, I have just 3 problems I want you to do, and then we'll go over the answers before you leave today. But I'm going to let you go with these 3 problems. It's on page 212 is where it starts. We're actually going to estimate some of this too. So, you're going to do number 17. So, page 212. On 17, you're going to do A and B. So you're going to find the equation and then you're going to estimate. Then you're going to do 23, just the model, and 26, just the model. So 23 and 26 is just the equation. And we'll talk about that before we go.